Hello guys, welcome aboard Apex Math. My name is Bino. In this video, we are going to differentiate the following function using logarithmic differentiation. The following logarithmic law will be applied. Suppose that we have the ln of a multiplied by b divided by c. This will be equals to the ln of a plus the ln of b minus the ln of c, where the a will correspond with the x raised to the power cos 2x, and 5x raised to the power 3 will correspond with the b, and the cos squared 3x will correspond with the c. So we apply log both sides of the equation. So we are going to have the ln y, which will be equals to the ln of x raised to the power cos 2x multiplied by 5x raised to the power 3 divided by cos squared of 3x. On the left hand side, we still have the ln y, and on the right hand side, we are going to have the ln, so we apply that rule above. The ln of x raised to the power cos 2x plus the ln of 5x raised to the power 3 minus the ln of cos squared of 3x. We have to know that the cos squared 3x can be written as cos 3x all raised to the power 2. We use another logarithmic law which states that the exponent of the expression inside the ln can be brought in front as a coefficient and be multiplied by the ln. So we are going to move the cos 2x and also move the 3 and the 2 so that they become the coefficient of the ln. So we have the ln y, which will be equals to the cos 2x multiplied by the ln x plus the 3 multiplied by the ln of 5x minus the 2, which moves from the exponent to become the coefficient of the ln of cos of 3x. From here, we can differentiate. The derivative of the ln y will be equals to 1 divided by y. Since we differentiated a function of y, we multiply this by dy divided by dx, and to differentiate cos 2x multiplied by ln x, we are going to use the product rule, where the derivative of the cos 2x will be multiplied by ln x and the derivative of ln x will be multiplied by cos 2x. The derivative of cos 2x is equal to negative 2 multiplied by sin 2x, and we multiply this derivative of cos 2x by the ln x plus the derivative of ln x, which is equal to 1 over x, which we multiply with the cos of 2x. Because of space constraints, 1 over x multiplied by cos 2x, we can write it as cos 2x divided by x. So now we differentiate 3 ln x. So we have 3 multiplied by the derivative of the ln x, which is equal to 1 divided by the function which is inside the ln, the 5x. And according to the chain rule, we also have to differentiate the 5x. So the derivative of 5x is equal to 5, but the 5 and the 5 will just cancel out, minus 2 multiplied by the derivative of ln of cos 3x, which will be equals to 1 divided by the function which is inside the ln, the cos of 3x. And according to the chain rule, we multiply this by the derivative of the function which is inside the ln. So the derivative of the cos 3x inside the ln will be equals to negative sin 3x. And according to the chain rule, we also have to multiply this by the derivative of the function which is inside the cos, the 3x. The derivative of the 3x is equal to 3. So we are going to have 1 divided by y multiplied by dy divided by dx, which will be equals to negative 2 multiplied by sin 2x multiplied by ln x plus cos 2x divided by x plus 3 divided by x, and the 2 multiplied by the 3 will be equals to 6, and the negative multiplied by that negative will be positive. So we have positive 6 multiplied by sin 3x divided by cos 3x, which is equals to the tan of 3x. We have to remove the 1 divided by y, so that we'll be left with dy divided by dx on the left. So we multiply both sides of the equation by y. So what we do on the left, we do on the right. And that y and that y will cancel out, such that the derivative of y with respect to the derivative of x will be equals to what we have on the right hand side of the equation. And in the place of that y, we are going to substitute the x raised to the power cos 2x multiplied by 5x raised to the power 3 divided by cos squared of 3x. So let's try to substitute this where there is y. So we have the derivative of y with respect to x. Thank you guys for watching. If you have any questions, you can drop them in the comment section below. Remember to subscribe, like and share the channel if you find this content interesting.